You know, we're getting really good at building AI that's book smart, perfect in a clean, predictable lab. But what happens when that AI steps out into the real, messy world? Well, it needs to get street smart, right? Today, we're exploring something called domain adaptation. It's this crucial skill that bridges that exact gap, and honestly makes AI truly intelligent.
Have you ever noticed this? An AI that works perfectly fine suddenly gets totally confused when you change things up? Or think about a spam filter that's amazing for your work email, but completely useless for your personal one. This isn't just a glitch, it's a fundamental challenge in AI, and it's exactly what we're going to tackle today.
So here's our game plan. We'll start with the AI's big blind spot, then we'll get into what domain adaptation actually is. We'll break down the 3 different kinds of shift it has to handle, look at the strategies we use to adapt, and then wrap it all up with why this really matters for all of us.
All right, let's dive right into this fundamental challenge. You can build an AI model that gets, near perfect scores on its training data, but all that perfection is hiding a really critical weakness. What happens when it finally meets a reality it wasn't trained for?
Okay, so here's the core of the problem. An AI learns from data in a very specific context. We call that the source domain. But the moment you deploy it in a new, even slightly different situation, the target domain, its performance can just totally nosedive. It's kind of like learning to drive on a sunny, empty racetrack and then suddenly being thrown into a rainy city during rush hour. Same car, completely different world.
This example makes the whole idea crystal clear. Imagine a spam filter trained only on corporate emails. It learns that words like invoice and report are totally normal. But now take that same filter and apply it to a personal inbox that's just flooded with newsletters and sales promotions. The patterns, the keywords, they're completely different. The AI is basically lost in this new domain. So, if the problem is an AI getting lost in a new world, the solution is to give it a map. And that, right there, is where domain adaptation comes in.
To put it simply, domain adaptation is all about taking the knowledge an AI has already learned in one world and intelligently transferring it so it works in another. The key here is that we're not starting from scratch. We're helping the AI adapt, evolve, and get smarter.
Now, it's not enough to just say the domains are different. To solve the problem, you have to understand how they're different. And it turns out these shifts from one domain to another really come in 3 main flavors.
So first up is something called covariate shift. This is probably the one you'll see most often. It's basically when the data looks different on the surface, but the underlying rules of the game haven't actually changed.
Let's go back to our spam filter. The specific words, the inputs, might change from my inbox to your inbox, but the fundamental idea of what makes an email spam is pretty much the same. So the data looks different, but the core task is constant.
Okay, next up is prior shift. This happens when the balance of the answers changes. So the inputs for a certain category might look the same, but how often you actually see that category is totally different now.
This is a fantastic example. Let's say you train an AI to identify hair color on a bunch of photos from Italy. It's going to expect a certain ratio of hair colors. Now, if you take that AI and use it on photos from Norway, the look of blonde hair hasn't changed, but how often it appears in the population certainly has. The model has to adapt its expectations.
And finally, we have the trickiest one of all, concept shift. This is where the actual meaning of the data changes. The exact same input now points to a completely different output.
And this is a really powerful example of why this is so critical. Think about medical diagnoses. A set of symptoms in one population might strongly suggest one particular disease, but in a different population, with different genetics or environmental factors, those exact same symptoms could point to something else entirely. The relationship between the input and the output has fundamentally shifted.
Okay, so we know the different ways things can shift, but how do we actually teach an AI to handle all of this? Let's check out a few of the main strategies.
The strategy we pick really depends on what kind of data we have from our new target domain. If we have a ton of labeled data, great, we can just fine-tune the model. But what if we only have a little bit of labeled data, or even none at all? Well, that's where the really clever adaptation techniques have to come into play.
One of the most intuitive ideas is called reweighting. What happens here is the algorithm looks at the new unlabeled data and says, okay, this new world seems to have a lot more of X and a lot less of Y. Then it goes back to its original training data and just gives more importance, more weight, to the examples that look more like that new world. Simple, but effective.
A totally different way to think about it is finding common ground. Here, instead of changing the data, you actually change the AI's perspective. The whole goal is to find a new way to represent the data where the differences between the two domains just disappear. It's like finding a shared language that both domains can speak, so the model can just focus on the task itself.
And a third technique is just so cool. It's basically a form of self-teaching. The model looks at the new data and makes its best, most confident predictions. Then, it pretends those predictions are correct labels and uses them to retrain itself, getting just a little bit better and a little bit smarter with each pass. It's this awesome feedback loop of continuous improvement.
So, we've walked through the problem, the definition, the different types, and the strategies. But let's zoom out for a second. Why is all this so incredibly important for the future of AI?
Here's the big takeaway. Domain adaptation is what lets AI leave the pristine lab and actually function out here in the real world. It's what makes our models more robust, more reliable, and more flexible. It also saves a ton of time and money because we don't have to go out and label a gigantic new dataset for every tiny variation of a task. Ultimately, it is a huge step toward creating AI that's not just powerful, but also general, fair, and truly adaptable.
And that kind of brings us to our final thought. As AI gets more and more woven into everything, our cars, our healthcare, you name it, the number of new domains it's going to have to face is just exploding. So the question I want to leave you with is this: what's the next frontier? What's the next complex, messy, uniquely human domain that AI must learn to adapt to? Thanks for tuning in.